Thermolysis is pretty interesting. Uh, Thermolysis is the breakdown of chemical bonds with heat. This will lead to subsequent combination in different forms in different areas of the star during its evolution into a life-hosting star. I have it linked right here. It's pretty interesting stuff, and I would assume a lot of this happens in various places on evolving stars as they cool and shrink. Ammonium dichromate on heating yields nitrogen, water, and chromium 3 oxide. Ammonium nitrate on strong heating yields dinitrogen oxide, which is laughing gas, and water. Ammonium nitrite on heating yields nitrogen gas and water. Barium azide on heating yields barium metal and nitrogen gas. Sodium nitrate on heating yields sodium nitrite and oxygen gas. This is very important. A few bonds can be made during one phase of the star's evolution when it's really hot, decompose in another phase, and then combine into another completely different composition. This would be much more complex and chemistry oriented than just saying rocks on the Earth are just squeezed together and heated via the rock cycle. I have found out that it is also geology that has been ignoring chemical reactions during earlier stages of a star's evolution into a life-hosting star like Earth. My best guess is thermal decomposition is similar to electrolysis, but electrolysis is electricity that breaks the bonds. With thermal decomposition or thermolysis, it's caused by heat. So it's a chemical decomposition caused by heat. The decomposition temperature of a substance is the temperature at which the chemical decomposes. It's usually endothermic, meaning it's heat absorbing to break down the bonds, meaning it's going to be cold. If decomposition is sufficiently exothermic, a positive feedback loop is created, producing thermal runaway and possibly an explosion. Very interesting stuff here. Calcium carbonate, limestone or chalk, decomposes into calcium oxide and carbon dioxide when heated. The chemical reaction is as follows: CaCO3 to CaO plus CO2. This reaction is used to make quicklime, which is an industrially important product. When water is heated to well over 2000 degrees Celsius, a small percentage of it will decompose into its constituent elements, which are hydrogen gas and oxygen gas. Now, inside of the interiors of stars as they evolve and the water is formed, it's mostly the reverse. It's synthesis reactions. The hydrogen combines with the oxygen. And under higher pressures, the thermal decomposition of oxygen and hydrogen from water would have to be a lot higher. It would have to be a lot higher temperature. So we can make a few predictions on the actual temperatures of evolving stars. This is interesting. The compound with the highest known decomposition temperature is carbon monoxide at 3870 Celsius or around 7000 degrees Fahrenheit. That's very interesting. So it means once carbon monoxide is synthesized during stellar evolution, it stays carbon monoxide unless you have something to break it down. That's really cool. I didn't know that. I'll have to include these types of high temperature decomposition molecules when I work on other parts of this theory. Unfortunately, it's taking a lot of time. It's very, very energy intensive. That's why I'm making these videos for my viewers, so maybe they can throw a bone my way or help out in any way they can. Basically, it's suggested that you stay away from pseudoscience online and try to explain stellar evolution and processes inside of stars using chemical processes, because you can test these. I've noticed Electric Universe doesn't really talk about chemistry very much. Establishment science thinks stars are fusion reactors and are nuclear, so they'll completely ignore chemistry. But chemistry is the bread and butter of stellar evolution. Without it, there are no evolving stars. But it's going to take a while for them to realize it. I'm just letting my YouTube viewers know earlier. If they want to work on some things or shoot me an email, go ahead. I'll be willing to listen.